today we're going to be exploring quadratics with graphing. Okay, so we're going to look at the coefficients of quadratic functions, these unknowns, and see how they affect our graph. We're going to do a little exploration action going on here. We're going to look for some key features of these quadratic functions. So to start, let's start by figuring out what does the parent function look like. Okay, so the parent function is the function that all quadratics are related to, the x squared. So the parent function is x squared. All quadratic equations are related to this one right here through some forms of transformations. So when we look at unknowns and stuff, we're going to look and see how these unknowns change the graph from the parent. So how do I graph something like this? Well, you make a table and you just plug in some numbers and see the shape. So I'll show you how to do the table in a little bit. So it's squared, so each of these numbers squared gives me the answer I'm going to be looking for. Negative 1 squared is 1, that's 4, and that's also 9. So I can graph these points on my graph right here to see the shape of the parent quadratic. And then 9, and this right here is 1, and 4, and 9. Okay, so to draw a quadratic, I usually do a nice, again, trying to do through all the points, nice smooth curve. Keep your hand to the table. Okay, turn the paper for the second half. You should be able to touch all the dots without moving the heel of your hand from the table. When you can, your hand will pretty much follow a curvature that will go right through all the points in a nice smooth curve. Okay, this is the parent function. This right here, as this point here has a name, it's called the vertex. It's going to be our major name, and we're going to talk about that as part of our key features. Okay, so this is what the parent function looks like. Let's write down some things about it, the key features and things that we're going to be using for this. So I'm going to move this paper out of the way, and I'll keep referencing it. So what are the key features that we have for quadratics? What are some key features? Well, it has a vertex. This vertex is the highest, which we sometimes call the max, or lowest, the minimum. It's the highest or lowest point on the curve. Okay, and this is where the graph turns. Okay, so one side of this graph is going to go up forever. The other side is going to come down to a bottom dip like this. So this is referencing the minimum. Okay, if it was upside down, sometimes the graphs will be upside down like that. Then these go down forever, and it has a highest point, which is called a maximum. Each of those things is still the vertex. Where it turns is the vertex. Every quadratic has an axis of symmetry. What is the axis of symmetry? The axis of symmetry is the vertical line through the vertex. That's what the axis of symmetry is. What does it mean? Okay, it means that when I fold the curve or the graph on this dotted line, then it will be a dotted line. So on this line, then the two halves will match up. So if I fold this over right on itself, the two halves are going to match up perfectly. And so you can see that in the table right here. So this is the vertex. So these 2 points match up, those 2 points match up, those 2 points match up. That's what they mean by the axis of symmetry. Okay? This is drawn a dotted line. Do not make a solid line. It is a dotted line. Okay? Very, very important to remember that when you draw it in there, because you don't always draw it, but when you do, it's a dotted line. Another key point that you want to look for is the y-intercept. What is the y-intercept? That's the point where the curve or graph crosses the y-axis. Some other key points that you want to look for. You may not always find them at this point in our exploration, but if you can find them, they are the x-intercepts. You could have more than one. You can only have one y-intercept, but you can have more than one x-intercept. So it is a point or points where the graph crosses the x-axis. So in the quadratic, you can have two x-intercepts, you can have one x-intercept, or you can have no x-intercepts. Okay, so that's the extent for the x-intercepts. So we're now going to look at the different forms that these graphs take. Okay, and then we're going to explore these a little bit. So we're going to look at the vertex form. Now the vertex form is the most common form at this level for you guys. Sometimes it is called standard form. I like to call it standard form because, well, I'll tell you why later. And then sometimes it's called transformation form. Standard form, transformation form, because you'll be able to see how the graphs and the unknowns affect the overall graph from its parent function. So that's what this is kind of looking at. We're going to see how these things do it. We want to know, oh, let me write down the standard form first. So the vertex form is y equals a x minus h squared plus k. So x and y are the variables, a, h, and k are the unknowns. So we want to ask these questions: how do the unknowns, which are a, h, and k, affect the graph from its parent? That's our first question. And then our next question is, what are its key features? So in this format, how many of these key features can I pull out, and how do I know what they are? So what are its key features? So we're going to do an exploration here. And I need to get to a different screen. So let me get out of this real quick. Come over here. And here is the vertex form. You can see they use different letters over here. They used A, B, and C, which is fine. It means the same thing as the ones I gave you. So let's take a look at this. And we have sliders here, so I'm going to change different numbers, and let's see how these things are changed. So here's a quick action here. So if I move the C, which is our K over on the other one, what happens? Look at the graph. This is the parent function right here. As I move C, make it bigger, look what's happening. So the one that's moving from the parent. So the C value is moving this graph up and down. Look at the equation over here. Whatever C is, whatever that number is, you'll see it here. And if it's minus, it'll have a minus sign at the end. And that means move the graph downward. Okay. And then positive is upward. Okay. So there's that one. What does the B number do? B is the number inside here, being they have x plus B. It's a bad form, but that's what they have. Okay. As I move it across, look what's happening though. See, if it says x plus 1, which way did it move? X plus 1, see, it's moving to the left. You see that? And then let's move it to the right. So that number on the inside moves the graph right or left. What does the A do? A does two things. Let's see if we can figure out both of them. So as I move this way, see, starting at 1, now I'm getting numbers bigger than 1. The graph is getting narrower. Okay? What if I move it smaller than 1 but bigger than 0? Still positive. Now it's getting wider. See that? It's getting wider. Now what happens if A goes negative? See how the graph turns upside down? I can't move it. So, and it uses the same technique. So as the A value gets bigger than -1 or smaller than -1, then it's going to get narrower, like so. See that? But the graph is upside down. When the A is negative, the graph is upside down. That's one thing. And then the narrower and wider aspect is the second thing that A does. So A has 2 rules. Okay? So let's go back over here and take a look at it. And let's write down some of the things that we have that we learned from that pictures. So what does the K do? I'll get a little bit bigger here so you can see it. K is this number right here, and it just moves the graph up and down. What does the H number do? H number moves the graph right and left. Well, how do I know which way? Here's how you can tell. What you want to do is you're going to take whatever's in the parentheses. So when x minus h equals 0, and solve it for 0, you're going to get an x equals number. Okay? When does that equal 0? When, in this case, when x equals h. So that's how you can tell. So if this number here, when you solve it, gives you a positive number, then you're going to move to the right. If when you solve this for x and you get a negative value, then you're going to move it to the left. And we'll explore that in more detail as we move along. What does the A number do? It does 2 things. It'll make the graph wider. And to do that, what do I need to know? Well, that means that A value, in case it's negative, the absolute value of that thing has to be between 0 and 1. So a number less than 1 but greater than 0. Okay? That's what the number, the positive value does. What else does it do? It'll make it narrower when the absolute value of the A is greater than 1. So it'll get thinner. Okay? What else does it do? If the A is negative, less than 0 means negative, then you have what's called a reflection across the x-axis. In other words, you're going to flip over the x-axis. Flip it over. Okay? I don't like this term, but this is basically what's happening. You should refer to it as the reflection across the x-axis because that's the proper terminology. Okay? Now, what key features can I find from this format that pop out to us regularly that we can see clearly? Well, the first one is, because of the name, you can see very clearly that it's the vertex form. We can find the vertex very easily. The vertex is the point h, comma, k. Now, how do I find h? This is how I find h. Not reading it from in here, but doing this and finding what h is. That's what h is, so that you don't get any sign errors. That's the number 1 mistake people make. You can also find the axis of symmetry very easily. I'm going to abbreviate here. And it is simply the vertical line, so you got to write it as an equation, x equals h. This, see, that's another reason why you want to solve for x. This also gives me the axis of symmetry. Okay, see, you just take that right over there. That's the axis of symmetry. H is the number that goes here. K, you just read whatever's right there. And there it is, very simple. Okay, so this is the vertex form. All right, let's go take a look at one of the other ones. And see how those numbers move around. So now we're going to look at what the books call standard form. Sometimes I'll call it general form. Because when they go up to the next level, they kind of change the names on these things for you guys. So here is the standard form. It's in that format right there. Some of you may be familiar with it. And again, we want to know how these letters will change the parent function graph. Okay, and then what are some key features that we can pull from this? Okay, so let's go explore that one a little bit. And so here is that one. Okay, so A, B, and C have already set up in here. And let's look and see. You can see that the A value, let's take a look at that one. Right now it's at 1. So if I go bigger than 1, excuse me, it moved on me. What is it doing? Again, it's getting more narrow. And if I go less than 1, it's getting wider. They're not going to give me too many in here, so just so you know. So what does it do? The negative, it just flips it over. So it's doing the same thing, just going narrower, okay? And so forth, okay? So A does exactly the same thing. You'll also notice that the vertex is also moving slightly with the A, okay? And so A has some effect on the vertex. We don't know how yet, but it will have a little bit of say-so in what the vertex is, okay? So what about B? What is B doing? B, look at it. It's kind of like the graph is doing in a weird action, right? It's going up and then around. See that? So the vertex is definitely associated with the B. Again, how that occurs, we don't know yet, but that's what the B does. Okay, and what is C doing? C is still just going up and down. Notice, okay, C is also going to be your y-intercept. Okay, so let's go take and look and write some of that stuff down. Okay, so we have it over here. What does the C do? This one moves the graph up and down. And it is also it's the y-intercept. The y-intercept is a point, so it would be written in the form of 0, comma, c. When x is 0, the y value is c. And you can see that very clearly in here. So that is the y-intercept in this format. What does the b value do? Well, it will affect the vertex. What does the a do? The a does the same as before. Okay? The same as the other. A pretty much is set in what it does. It doesn't really do anything different than the same things I showed before. Okay? So the y-intercept, we know. Here's the one that's more challenging, the vertex. The vertex is the most important point in a parabola or quadratic equation. We have to be able to find the vertex. So for this one, remember I told you that the A affects it a little bit and the B affects it a lot. So here is how you can find the vertex. Okay? The x-coordinate of the vertex is found using this little formula, negative b divided by 2a. So whatever b is, you're going to put a negative in front of it, and 2 times a. So you see how b and a both affect the vertex. Once you find this, you're going to plug into your equation to find the y value. That's the y coordinate. That's what you need to do. So this one's a little bit more involved in finding it, but you have to find that first. And then again, the axis of symmetry is exactly whatever that value is. So it'd be the equation y equals negative b over 2a. Okay? So that's how that works. And again, we're going to do an example, and I'll show you how you go about doing all this. But we have one more form to look at, and this one is called the intercept form. Okay? Also called the factored form. And it is y equals a x minus p x minus q. Okay? So we're going to look at those, and let's see how these things change according to our here's our intercept form. So again, looking at the a, you can see that a does exactly the same thing as it has always done. If I get smaller, it gets wider. And if I go negative, it flips over the x-axis. Same process. So that's a. What is the b? B and c are these numbers in here. Again, they did a different form than me. I like the x minus because that's the actual format. This is not the actual format. But look at what's happening. Watch the thing. This is the intercept form. So look at where the x-intercepts are. Right now, they're both at 0. But as I move it, see how it's changing? Look at my equation, x minus 3. I'm at 3 here, aren't I? Okay. See? So it's giving me these x-intercepts. Okay, so you can see that the vertex is affected by these x-intercepts also, and we'll explore how to find them, but that's what these do. So this format gives me the x-intercepts. So that's what this one does, and that's the importance of it, okay? So when we do this problem over here, when we write stuff down, we can see that the A is the same as the others, and then P and Q are the x-intercepts. Okay? Important points. These are very important points in our work. So the x-intercepts are written as points P0 and Q0, x-intercepts. Now, how do I find that vertex? Okay, it was harder to, it was kind of hard to see in there, but here's how we find it. Just like this one, it causes a little bit of work, but because of the symmetry of the graph being the axis of symmetry and all, these things are the same distance from the vertex. Okay, and so that means the vertex must be, so the x-coordinate of the vertex is the average of the two x-intercepts. In other words, it's halfway in between. Add the two x-intercepts, divide by 2, and that is the x-coordinate of the vertex, to which you then plug in to find the y value. Okay, so that's how you find the vertex. And again, the axis of symmetry is the line that goes through the x-coordinate of the vertex, so it'd be x equals whatever p plus q divided by 2 is. Okay, so that's how that works. So these are the three forms that we're going to be exploring quite extensively in here and using quite often. So we want to be familiar with all three of them, but also we want to learn how to graph these things. So how to graph quadratics. I'll call quadratic functions. How to graph quadratic functions. Here we go. Step 1, find the vertex. That is the most important point. You need to find it. Okay? So whichever form I give it to you, use the process for finding the vertex. And then we go on to the second step, which is you're going to make a table with the vertex in the middle. Okay? Then what? You're going to pick two numbers above this vertex number and below. What numbers could you pick? Any one you want. Okay? It doesn't matter. So you can pick numbers that give you nice integers. So you don't need the next two. Most of the time you just pick the next two up and the next two down. But you can pick whatever you want. And these can also be any intercepts that you know. If you don't know an intercept, you don't need to find it. You can pick any numbers you want. But if you do know the intercepts, go ahead and use them. That way you can save you some time. You may need a third point to draw the shape. So you want to have a nice parabola shape, like the parent function. It should look something like this, nice and tall or nice and long, and so that you can see this curvature, what it looks like. So if it's too small, too narrow, that's not big enough. You may need more points to get a nice smooth curve actually going on. So that's what that means. So you want a good shape. All right? And the last one is you need to label the vertex, okay, and a point on each side. And these can also be the intercepts if you know them. Okay? So label the vertex and a point on each side as a proper labeling. So in the parent function, I can label the vertex as 0, 0. I can label this point 2, 4. I can label this point over here if I want, or any one of these points over here, -2, 4. And that's the vertex labeled, and 1 point on each side of the vertex labeled. If they ask you to draw in the axis of symmetry, then you would draw a dotted line through the vertex, a vertical dotted line, but only if they ask you to. Otherwise, you do not need to draw it. Okay? If you have any kind of intercepts, you can label those also. Okay? So this is how we're going to graph. So let's go do some graphing. I have a couple of problems here we're going to look at, and then we'll call her done. So here we go. We're going to graph this one. You can see that this one is in vertex form. So we're going to go through the process for finding this out. So what I asked everybody to do is what? Take the stuff in the parentheses, set it equal to 0, and solve. So adding 1 to both sides, x equals 1. This tells me then that is h. That is h, that is k, and that is my vertex at 1, 8. To make our table, this number goes in the middle. So 1, 8. Pick two numbers above 1, don't overthink it, and two numbers below 1. And then plug those numbers into this formula and find the values. For the sake of time, I'm just going to go ahead and do that. At 0, if I plug in 0, I'm going to get a 6. If I plug in -1, I'm going to get 0. Plug in 2, I'm going to get a 6, and then a 0. And then one more point for shape. If I plug in a 4, I'll get -10. Once your table is filled in, we come down here and we draw our picture. Label your points: 1, 8, 0, 6, -1, 0, 2, 6, 3, 0, and 4 was -10, but I can't graph -10. I don't have enough room, so that's enough. Just know that you aim for -10 as you go around. Draw your curve. Make sure you can hit all these points. Aim it down. Okay. Draw your curve and aim for -10. Try to avoid the little pointy things up here. Don't make it a nice sharp corner. Make it a nice smooth curve. And then we want to label some points. You'll notice that I have a lot of points here that are intercepts. I'm going to label them all. If you have them, you should label them. Even though it's more than it was required, these are x-intercepts and stuff. And this one is 3, 0. Okay? So I've labeled the intercepts and stuff. If I need to draw the axis of symmetry in here, then I know it's a vertical line through the vertex, and it is a dotted line. So draw a line, arrow, arrow, and label it x equals 1. So that's what that graph would look like. The axis of symmetry is x equals 1. The y-intercept is 0, 6. Okay? I can also label the x-intercepts or title them, but that's enough for now. And there you go. Okay? There's that graph. One more, and then that's all I have time for. And we'll do this one right here, show you how to go through this one. This one is in standard form or general form, and the first thing you have to find is the vertex. Remember, you're looking for negative b over 2a. This is the a, this is the b, and this is the c. So as I do this, it's a negative, and I put parentheses, 2a. Then plug in the numbers. B is positive 12, and a is positive 4. You work this out, you simplify it, and you get a negative 3 over 2. Okay? You're going to get a fractions. We got to learn to deal with them. Take that number and plug it back in to find the y coordinate goes with this. So then I'm going to have 4, then negative 3 over 2 squared, plus 12 times negative 3 over 2, plus 5. Working this out, this is going to be 4 times 9/4. This is going to be, if you look at it, this is going to be, this divides that to 6. 6 times that is going to be a negative 18 plus 5. The 4's drop out here, so I have 9 minus 18 plus 5. 9 minus 18 plus 5 is negative 4. Okay? So that means my vertex is going to be at a negative 3 over 2, negative 4. Okay? Now, I need two numbers bigger than this. So usually what I do is just the next two integers up. This is a negative 1.5. So negative 1 is on this side of the number line, then a 0. I might need a third point, so I'll just go and put the next one there. This side over here is going to be negative 2 and then negative 3. And then you take these numbers and you plug them into this equation, and you find the y value that goes with it. Just for the sake of time, here's what I end up with. This is negative 3, this is 5, this will be negative 3, and this is 5. And I don't need that one over there. So that's how that works. You come down here and you graph those points. The vertex is negative 1.5 and negative 4. So negative 1.5 and negative 4, that's my vertex right there. Negative 1 goes to negative 3. Negative 2 goes to negative 3. 0 goes to 5. And negative 3 goes to 5. So you can see the shape right there. Okay? If I put a 1 in here, you can see it's going to be very large. It's going to be beyond the scale. Okay? So we draw our curve. We label our points. Negative 3 over 2, comma negative 4. And we label a point over here, 0, 5. And we label a point over here, negative 3, 5. And so that graph is drawn. If they want you to put in the vertical axis, the axis of symmetry, then you again draw it as a dotted line right through. Make sure it is a dotted line. and you arrow, and you arrow, and you name it. Negative 3 over 2. Okay? So that's what you would do there. The y-intercept is just that number right there. So the y-intercept is very easy to find. That's 0, 5. The axis of symmetry is x equals negative 3 over 2. Once you find it over here, you can just write it over there. Okay? These are your identifying major points, and that's how you will graph a quadratic. We'll do the next form in class together because I am out of time.